And there won't be any slides today. I'm just going to have pictures of me. No. I want to welcome everybody to this year's Brown Bag opening series. We're trying to do a few things new this year, so bear with us. But one of the things we want to do is try to have a webinar approach, and we have a few folks listening in right now. So that also means if you can't be here or want to attend through the webinar, we'll have this service available. What this also means for the folks who are on the line is please make sure your mic is muted, your video is off, and if you want to communicate with us with questions or anything like that, please just send a chat, okay? So with that, I'm going to get off the camera. And we'll go to the slides. And we should be good to go. Okay. Did I not share? I didn't share. Okay, right. Okay. Okay. We'll get this right soon. All right, so I'm Drew Gitomer, and I'm on the faculty here. I'm also one of the folks coordinating the Brown Bag series. We've got a number of other folks who are helping with that. Rosemary Carolyn, Anna Marone, Clark, Chin, Beth Rubin, and Ariana Manuel Figueroa are all on the committee. So if you've got suggestions for folks who might give talks, please contact one of us, and we'd be happy to do this. So today I want to talk about, introduce a project that we've been working on for 5 years. Eugenia Etkina is one of the co-PIs on this project. I'll introduce the rest of the team. But what we've been concerned with is studying particularly teacher knowledge and more generally the issue of teaching quality and how to measure that. And so before I begin, let me introduce folks here. There we go. Okay. So this is a multi-institutional project. At Rutgers, we have Eugenia, Rob Zisk, and Charlie Iaconangelo all worked on this project. Stamatis Vokos and Lane Seeley were at Seattle Pacific University. Stamatis has since moved. Jim Minstrel and Ruth Anderson, science educators and researchers from Facet Innovations in Seattle. Courtney Bell and Jeff Phelps are at ETS, and Sean Smith worked with us from Horizon Research. So any of the work that I'm doing is the product of lots of folks thinking. Okay, so the work begins with a general sense of how we understand teaching quality. And when we look at research on measures of teaching quality and how it's been evaluated, it's generally characterized by work that use correlational kinds of approaches between different measures of teaching. It's sort of embodied in a project that was quite well distributed, the Measures of Effective Teaching Project. And those measures can include things like teacher characteristics, their backgrounds, their knowledge, classroom artifacts, observations, value-added kinds of measures based on student learning and student perceptions. And the body of work can be sort of quickly summarized by saying these correlations tend to be fairly modest. And while they may describe patterns of relationships in terms of simple correlations, they really don't help us understand those relationships. So what we're trying to do is do a little bit more on that. And And we're asking the fundamental question is what knowledge, skills, and practices the teachers need to effectively teach the subject matter content to students. And we're interested in how we can measure those knowledge, skills, and practices, and how we can validate score interpretations of such measures. And when I talk about looking at teaching, I want to just sort of start by saying, you know, we're really focused here on the teaching of content and subject matter. So we're not looking here at sort of moral and social dimensions of teaching, except to the extent that they affect the conveyance of content and teaching of subject matter. Now, we focus on content knowledge of teaching, and that's the content knowledge used to recognize, understand, respond to range of content problems encountered in teaching practice. So it goes beyond simple content. And the idea here is that content knowledge is necessary, but it's not sufficient for effective teaching. That there's this body of knowledge of how teachers know their subject, know their students, and are able to teach students. It comes out of the work of Lee Shulman and pedagogical content knowledge, Deborah Ball and colleagues. Most of the work's been done in mathematics, but other subject matter areas have been explored as well. And this current work was studied in the area of physics, specifically mechanical energy in physics. To give you a quick sense of the difference between content knowledge and content knowledge of teaching, let me give you a quick example. So if we're looking at teacher subject matter knowledge, say in elementary science, it's elementary mathematics rather, we might ask them to solve the following problems. So I'm assuming that at least some proportion of folks here can solve these problems. Is that right? Especially our math experts. Okay, so so this is fairly straightforward, and people can solve this problem. But when we think about content knowledge of teaching, we'd ask this in a different sort of way. So here's a problem where we say a teacher's teaching a lesson on exponents. She wants to give her students quick problems at the end of class to check their proficiency in evaluating simple exponential expressions. Of the following expressions, which would be least useful in assessing student proficiency in evaluating simple exponential expressions. And so the answer here would be, volunteer? D. So they're all equally useful. Okay, other nominations? So this is a little harder, right? A little more challenging than just solving the problem?
Maybe C, because 2 squared is 4, but 2 times 2 is 4. So
Great.
students might be confused. They might not solve the
Right. So if the student answers 4, you really don't know. Do they answer? And if you're an elementary teacher, you know that kids get mixed up. They might add 2 plus 2. They might times 2 times 2, or they might actually put 2 to the second power. And so 4 doesn't tell you whether they understand or not. But if they have one of those misconceptions, they're going to come with different answers if it's, say, 3 cubed or even 2 cubed, right? Okay. So a teacher familiar with mathematics, familiar with their content, would pick up on that very quickly. You know, because we're not teaching those kids, have to sort of work through and infer this sort of thing if we do that, but it still be much more challenging. And by the way, when we gave this to elementary teachers, about 50% of those people get this item correct. So that's a different set of issues. Okay, so the fundamental validity questions about CKT are this. Is it really a thing? Is there some body of knowledge, of content knowledge of teaching, or is it really just content that knowledge in a different sort of form? And so we'll explore that a little bit. And then, does it matter for teaching, and how does it matter, and does it matter for learning, and how does it matter there as well? I'm going to focus today primarily on the teaching aspect and not the learning piece. That can be a subject of another sort of seminar. Okay. So what's validation? You know, we talk about assessment validation. This comes from Messick, who's sort of the godfather, one of the godfathers of validation. It's an overall evaluative judgment. So it's not a simple number, a numerical kind of thing. There's a judgment that looks at both empirical evidence and theoretical rationales to support the adequacy and appropriateness of interpretations and actions that we take on the basis of scores. So we're not simply saying a test is valid, we're saying some interpretation of the scores from that test are valid for a particular kind of use. Okay, and we're looking at this complex evaluative judgment based on an array of evidence to make that judgment. But when we look at how we validate measures of teaching measures, and for example, content knowledge for teaching, what typically happens is you develop a measure of CKT using items like the one I showed you, and then you look at relationships, correlation relationships with scores from other teaching quality measures. And that work has been done. And to the extent that these scores are correlated, we say, okay, we have evidence for the validity of CKT scores as a measure of teaching quality. Now, these relationships between measures of teaching are generally quite modest, 0.2 neighborhood, maybe even less. And so that's sort of where the field has been. But this way of validation is what Messick called a very weak construct approach. So if we have a set of tasks and that where there's not a real understanding of the relationship between those tasks, other than sort of saying, well, we know they're all related to teaching, and that you then just try to do by brute force establish these correlations, you wind up with something that's not very satisfying in terms of the validity and why these things matter together. So that's sort of where the state of the field has been. So we came to this project and said, you know, why don't we try to do something a little bit different? And we wanted to do that by addressing three challenges in validating measures of teaching quality. And these are problems that are associated with measurement in general. And one is that we often underrepresent constructs, right? So you've heard lots of critiques of tests. They say, well, they don't get at all sorts of things that are important to teaching. And so they only take a slight cut on a particular construct. Well, what we sort of said, look, when we're looking at a complex performance, it's not a critique of the test to say that it underrepresents it. It's a necessary truth that any single instrument is going to underrepresent a domain. So we need to start thinking about these things in terms of multiple sorts of instruments and not simply a single instrument to represent a complex performance domain. The second problem is that we have these weak theoretical links between measures. So even if a measure has a strong theory underlying it, so you know you have an observation measure and you have Danielson's theory underlying it, if they're not connected at all, you lack a sort of coherent perspective on how these things are related. There's not a unifying theory. And the third piece is that we sort of have weak evidentiary connections. The connection between evidence are weak. And by this I mean, if I take, if I'm looking at observations over the course, I'm sampling across the course of a year. If I'm taking student learning using an achievement test over the course of a year and learning that may have accrued over several years, and if I'm taking teacher knowledge measures that cover large swaths of the curriculum, then it's very difficult for me to sort of focus in on what the relationships between these things are. What I have are general traits. I say, well, if I look at observations generally, the teacher acts in a particular way. And I can look at how the students learn. But they're really these general traits that don't really give me an insight into the nature of knowledge and behavior of teaching. So we said, let's try this something a little bit differently. We said, let's first develop multiple measures of a common domain that represent the totality of that domain. Let's build all of these measures from a common underlying domain model, sort of unifying theory. And then let's collect evidence within a more constrained domain, a single unit of instruction. So basically what we want to say is, look, what does a teacher know about this domain? How do they teach it? And what do kids learn about the domain? In a much tighter sort of thing. So we can look at those relationships. So the guiding questions, well, just are these three questions. What do they know? How do they enact instruction? And what do students learn? And all related to the knowledge that they have. Okay, so the common theoretical framework, we start by saying that content knowledge for teaching comes out of practice. We're interested in not just the abstract knowledge teachers have, but it's the knowledge that they come to use within disciplinary practice. And the theoretical framework has two components to it. One are tasks of teaching, what a core instructional practice is that teachers engage in. And the second is, what's the stuff that they're practicing around? What are the knowledge expectations? In this case, because we're focusing on mechanical energy, we look at energy targets. So to give a sense of what these tasks of teaching are, at a very broad level, you can look at these things and say, well, these apply across domains, and they do. But then we bring them down to more specific levels, and so we get, if we begin to start looking at, if we look at anticipating student thinking, we start then thinking about, well, what are misconceptions that students might have, or partial conceptions that they might have in science, and thinking about kinds of tasks that get more and more specific to the particular domain that you have. So we have about 3 levels that get more and more particularized to science and even physics in some cases. Then when we think about the targets, these are targets that are the core ideas within a domain. So for energy, on the left side, we have things like connection of energy in everyday experiences and choice of systems, and then we have some specific sort of sample targets underneath that. So we now have a very specific definition of what the knowledge that we expect teachers to know in this particular area is. I reversed that. Okay, so the point of this is that what we then see is that content knowledge for teaching represents the intersection of the tasks of teaching and the energy learning targets. Okay, and that's how we define this domain. So as a simple example of this, if we have a task of teaching, provides opportunities to analyze an experiment using various conceptual frameworks, and the target is differentiating between force and energy. The enactment of that might be that we ask students to compare the gravitational force and change in gravitational potential energy for an object near the floor that is raised to near the ceiling. We give them a task like that. Okay? All right. So now we develop multiple measures, and for looking at this broad domain of content knowledge for teaching. So we start with an assessment of content knowledge for teaching. We have classroom observations. We look at classroom artifacts, the assignments and assessments that teachers give to their students. We interview the teachers before and after they teach a unit of instruction, and we give students tests of what they've learned in the area. We also have pre-tests so we can control for prior expertise achievement levels. Okay. So let me go sort of try to contrast now the framework approach that we're talking about. In the traditional model, what we have in best cases are situations where each measure has a particular framework underlying it, right? So we know that you guys are familiar with observation measures. They have frameworks underneath those. We have any test is going to have a theory or a model, some sort of framework that guides the development of that measure. And then we have a knowledge measure, and also there we may have a well-developed theory. But the connections between these are absent. So what we're left with is looking at empirical relationships, correlations between these various measures. And if I contrast that then with what we've tried to do is we start with this common framework that's built around the task of teaching and targets, and all of our measures then are derived from this particular framework. And different parts of the framework, I'll go into this in a second, will tap into different measures. But now we can look at these correlations between these measures, but they're all mediated by the same sort of theory. We can talk about this in a common language about the relationships between these various measures and understand these relationships in a very different kind of way. And so what we've got is when we look at things, these different measures, you'll see that these measures are in the middle, and these different sorts of key tasks of teaching actually, and outcomes that we're interested in, each of these kinds of measures differentially taps different kinds of information. So if we want to know teachers' goals, the best way to find that out is to ask them. And so we do that with teacher interviews. Now we can get at some of their goals through assessments and artifacts and things like that, but that's going to be a much more highly inferential kind of task. If we're interested in how they design and select instructional experiences, artifacts are a very direct sort of piece of evidence for that. So you get a very a thick arrow that goes to that. All of the information from the assessment itself, you'll see the connections are all light. I mean, we get some information, we can make some inferences, but they're not nearly as direct as they are as the kind of inferences that we can make from practice. So this is the sort of model that we work with, that we use to guide our analyses as we think about these issues. Okay, so let me go to the designing a CKT assessment. We wanted to see how test takers apply content knowledge to particular work of teaching. So we could have an example: students are discussing energy conversion when dribbling a basketball on a wooden floor. That's the target, the content target. There are a variety of beliefs and understandings expressed, and the teacher is then asked to choose an activity that would help students resolve those issues. So we have a scenario here for time interests, we won't go through all of this, but essentially this problem presents that scenario. We have a few number of kids' statements about what's going on, and then we see two types of questions. All these items are situated in teaching contexts like the one I just showed you, but some can be solved just by appealing to disciplinary knowledge. We call those CKTD items. You don't really need to take the perspective of the student, what they how they understand things, what would be good instructional moves. You're really just solving a disciplinary item, albeit within a teaching context. And then other questions need to consider these pedagogical issues, such as student thinking and needs. We call those CKTP, pedagogical items. So the disciplinary item would be something like this. Marcos, one of the students, gave an explanation for what's happening, and the question is the kid right that the elastic energy of the floor and the ball would be the same? And these are the options. These are simply physics kinds of problems, and people respond to that. The second item is begins to get at the pedagogical issue. So which of the following activities would be most likely to provide the students with additional insights about the relative amounts of elastic energy? I'm not going to work through the, we'll go through this quickly, but the point is that the teachers need to take into account what are the most effective sorts of examples, what are the pragmatics of doing things within classrooms, and the tools that they have, and all sorts of issues that they come in and make a choice about one of these particular choices. Okay, so we had a test. We had 26 items associated with 15 scenarios. We administered this to 329 experienced physics teachers. And when we look at these are standardized scores based on our IRT model. We see that there's a very broad distribution of scores here. Follows essentially a normal distribution. And we also looked at undergraduate majors, and as well as experience. What we found is that people with physics undergraduate majors, engineering majors, did better than those who taught biology or came from other kinds of routes. So having strong content knowledge really does matter in how they did on this test. We didn't find any differences with physics experience. These were all self-selected people from across the country. So it wasn't any sort of, deliberate sampling kind of approach. Okay. So, what we find is we're able to model learning targets and tasks of teaching within these assessments. We did have adequate fit with our assessments, reasonable reliability, and we find that subject matter preparation was strongly associated with assessment performance. Not surprising. Okay, so we have this measure of assessment. Now we look at enactment. And we look at enactment through both classroom observations and classroom artifacts. So we conducted an intensive study with 32 teachers, and we basically tracked them as they taught their energy units, which could be anywhere from, say, 2 to 4 weeks of instruction. We video recorded all lessons. We collected artifacts, including final assessments from each classroom. For the 3 of the samples, we would collect student work as well, or all the samples, we'd collect samples of student work as well. We had pre and post tests for the students, and we had pre and post unit interviews of the teachers. Okay. So with observations, what we're saying is when you look at an observation, you don't get a direct measure of teachers' knowledge, right? I mean, but the assumption, the theory is that teachers with differential knowledge are going to carry out tasks differently within their classrooms. They're going to do certain things in ways that are different than people that don't have this sort of content knowledge for teaching. And so we should see higher quality teaching. That's at least the expectation. And so we're interested in we designed a protocol for this. We're interested in the characteristics of that protocol and what would the relationships between the practices and their CKTE. So we came in with this is a brief overview of the system. We have 6 dimensions on 4-point scales. We had 6 raters. We coded or scored between 6 and 7 lessons from each teacher, although we collected, say, 6 to 25 lessons, depending on how long they taught. We coded in 15-minute segments, and then we averaged from segments to lessons to total scores, and we have all those different kinds of measures. And so these were the dimensions that we had. We looked at lesson purpose and coherence, the errors that teachers may have made or let live within the classroom, the depth of content, the kind of discourse that went on in the classroom. And we also had a more generic kind of measure of management that looked at behavior and time use. And we wanted to just have that because this was the one thing that was sort of a more general. We wanted to see if this was a limiting factor or an enabling factor in particular kinds of classrooms. But you see everything else is very much focused on instructional dimensions, not the kind of environmental things that you also see in protocols, given the focus of this project. Okay, so what we see is that scores are pretty well distributed. In terms of overall scores, we see that they tend to be somewhat lower in discourse and content than they are, say, in management, which is higher. We don't see lots of errors. And we see but we see scores that generally are somewhat higher than you see in lots of other observation protocols when you look at scales in research studies. And I think, you know, we selected teachers through lots of networks. In New Jersey, we had lots of teachers through Eugenia's network. These tended to be relatively strong teachers. So we still have a large distribution, but we have a lot of stronger teachers here. We also, in general, physics teachers tend to be stronger in their content areas than in other, you know, when we look at, say, elementary teachers. Okay. We did a generalizability study. This allows us to look at sort of what's contributing to variation in the scores. And what we see here is that we get a significant relationship, or teachers, scores differ with respect to teachers, just on the total scores. But we also find that we have lots of lesson and segment variance. Now, when in many teacher studies, people see this as a problem, right? You see this as a problem because, you know, you want to get a stable estimate. So how many lessons do we need before we get a stable estimate that we can give a teacher a score? But when we take this approach, one of the things we have come to discover is that actually this is really important information. And why would you, once you start really well clarifying what you're looking at and how you're looking at this thing in the concept of teaching, why would you expect all these dimensions to be high at every segment? There's a, you know, there's this pattern of teaching that occurs and this flow, and you would expect lots of variation. So having this isn't sort of the noise that sometimes, or troubling data that sometimes gets associated to research where you're just trying to get a stable estimate of a teacher. But when you're trying to understand teaching, this variation is actually really important information. What's really useful, though, too, is that we don't have a lot proportionally of rater variance here. Okay, so we're not getting lots of problems with noise on the raters, and that suggests to us that, you know, you could take other well-trained raters and substitute in and get similar kinds of results. When we look at relationships, you know, we look here, the total score, we have a correlation of 0.45 with the knowledge measure. We have several dimensions that are carrying that load, but the point is these are much stronger correlations than we typically find in the field. And we think it's because we are, you know, focusing on a particular area, particular domain, where we can establish those relationships much more clearly than having these more gross sorts of measures that are typically applied. Okay, so, you know, we found that the observation protocol has promising psychometric evidence, and we did find substantial differences across classrooms, and as I mentioned, the correlation looks pretty good. The artifact work, this work has been led by Rob Zisk. We follow the same sort of logic as with the observations. We're assuming that that when teachers, it's not a direct measure of knowledge through an artifact. We expect them to do things differently. Artifacts have this unique thing of making clear, less so in physics, but at least to some extent, there's lots of times where teachers are giving kids tasks that are not of their own design, right? And so you have to be careful about what the attribution is in terms of, is this about the teacher or not? In physics classrooms, to a large extent, these are teacher developed or selected kinds of instruments. Okay. So again, we're looking at the same sorts of questions, the psychometric characteristics of the instrument, as well as the relationship with the knowledge measure. And so this structure, we describe in each artifact the targets that are being used, the science practices. So we're trying to map this over to the NGSS kinds of things. We sort of count errors that are present in the artifacts if there are things that are just problematic. But the dimensions, we have 3 dimensions that we focus on. We look at analysis of problems and phenomena, we look at the mathematics required, and we look at the representations required. And so here's an example of the mathematics dimension for the 4-point scale. At the bottom scale, there's really it's absent. There's no mathematics. We move up the scale to things that are much more formulaic, routine, recall kinds of things. In mathematics, can they use an equation, a definition type equation to solve for variables? As we move up the scale, we start seeing more applied use of the mathematics to the highest level, where they're actually using the mathematics to solve a problem of physics. And so this is the sort of thing we looked at across items and across assessments and across artifacts as well. What I'm reporting here are just the final assessments. We looked at the final unit assessments separately from other selected artifacts. The final assessment is a place where, teachers say, here's what was important for you to learn. So it gives us some insight into that. We have a 1 to 4-point scale. You can see that mathematics was actually the highest scored dimension. We have pretty high variation across teachers. We find that use of representations tend to be lower than other dimensions. And we did a G study here as well. Here, for the final assessment, we only have one assignment. We find that there's almost no rater variance. It's all at the level of the teacher. And so that's a very good thing to do. When we looked at the assignments themselves, we find much more variation associated with assignments that, teachers give different assignments with different purposes, and they'll vary with quality. Some will be more ambitious than others. But again, we found very low rater variation. So that's encouraging. Here, too, we found a strong, modest in terms of overall correlations, but in this world, a very strong correlation of 0.43 with the final assessment, with the knowledge assessment. And so again, these are stronger relationships than typically are found. Okay. The next part of the study was, so is CKT different from content knowledge? And so the claim, the theory is that content knowledge is necessary, but it's not sufficient for the development of content knowledge for teaching. And when you look across studies, you see a very high relationship between any measures of content knowledge and measures of CKT in studies of teachers. And so that then raises a question. Maybe all of this is just content knowledge, but maybe that we've studied it sort of in a way that limits our interpretation. Specifically, we're only looking at teachers. So if teachers have content knowledge, if the teachers don't have content knowledge, we're assuming they're not going to develop the pedagogical knowledge. And if they do have the content knowledge and develop the CKT, well, they've all gone through teaching experiences. So the question is, could we ferret this out in a different kind of way? And so specifically, what would happen if we look at people who had similar content knowledge but no teaching experience? What would we see? And so we said, why don't we look at undergraduate physics majors? These are people who all are taking physics and know physics to some, to at least a level that the many, and maybe a level of, and maybe more than many of the physics teachers. Remember, we have lots of people teaching physics who don't have physics or engineering backgrounds. And remember, we had those two item types, right? So we took advantage of that. We have the ones that are assumed to only involve disciplinary knowledge, and others that are assumed to include disciplinary and pedagogical knowledge. And so we developed 3 classes within this model. We use cognitive diagnostic modeling that Jimmy De La Torre has sort of been one of the leaders in. Many of the students have been working on it. Charlie has been, did his dissertation in this area. But the idea is that we said, look, let's think of 3 classes of individuals. Those who haven't mastered either the disciplinary or the pedagogical, those who only mastered the disciplinary but not the pedagogical, and those who mastered the disciplinary and the pedagogical. And would we see differences between the physics teachers and the physics majors? And so, you know, we want to know, are physics students more likely to be in that class that has disciplinary knowledge and not pedagogical knowledge. And so overall, when we do this analysis, we find that taking all 600 odd people together, 60% of the people are classified as not having either knowledge, 14% as having disciplinary only, and 27% having both. But when we look at the teachers, we find that actually the teachers are what we would expect if we have a very high correlation between the two. You're either you don't have either, or you have both. And there's not many people living in this space at all. But with the physics students, we get a very different thing. And these percentages are the percentages within columns. And we see that for the physics students, 25% of these people are in the disciplinary only category. None are in the pedagogical category. And overall, the physics students did a little less well than the teacher sample. And that, we think that may be because they're studying physics broadly over many, many courses, whereas the teachers have done that, but now they're focused on the stuff that they teach. So they may actually have a better grasp of that particular area, only because they've, even with similar physics background, generally, they're focused on that content area. But the point is that we do actually see some evidence here that we get different patterns, and we do see people who have disciplinary knowledge but not pedagogical knowledge, but really only in the student sample. So that sort of adds to the construct of content knowledge for teaching.
Question: did you look for teachers who had pedagogical knowledge but not the content knowledge?
Right. So. Right, so we constrained the models to have that. We are starting to test that further. We don't think there's anybody in that group.
I was just thinking, especially given those results, in some way, well, like I've seen this with elementary teachers who actually learn some of the content through working with students. So I was wondering if that's another explanation for why you might not have just straight content knowledge. So I don't know. I was just wondering if that.
Yeah, no, I think that's right. That one way to learn it is through teaching. Okay, so let me close by saying, what we've been finding and what we're is that we've been able to develop this suite of instruments, measuring knowledge and practice, all coming from a common framework. The psychometric properties of these various instruments are good, and the relationship with knowledge measures are relatively strong, stronger than have appeared in the literature. I didn't explain this, but we are seeing moderate relationships with student learning, which are also higher than we've seen in typical studies. And I think what this all does is it helps us understand better the relationship of knowledge and its enactment, and that we may, when we simply use the sort of correlational measures that we've used in the ways that we've used them, we may be underestimating the importance of certain kinds of skills, knowledge that teachers have, the relationships between measures, because we're using fairly crude approaches that don't allow us to really see what those relationships are. So practically, are we going to develop an assessment for each particular area? No, this was really a demonstration in principle that these constructs really matter and they are important, and but that but from a pragmatic sense, I don't think there's the capacity to develop all these specific measures for every unit of instruction, obviously. But the one thing that we are now doing is we're conducting case studies, which also include the analysis of the interviews, to better understand sort of the how their knowledge influences their practice. And so that kind of work complements the more quantitative approaches that I shared here, and I think will are giving us much deeper insight into the nature of content knowledge for teaching, its relationship to the quality of teaching. We've also conducted cognitive interviews of people who've taken the assessment to see how they solve the problems, because so many of the items we gave were selected response. You're just picking an answer. Some were constructed response that we want to see that whether what we think we're asking students to do, the kind of reasoning we think we're asking them to engage in, is actually the kind of reasoning that they're engaging in, and that the reasoning that we see sort of agrees with the sort of scores that they get on the assessments. So that all work is all underway as well. So I'll close here and open it up to questions. Do we have anything from the, oh.
Can you repeat the questions?
Sure. Okay, any comments or questions? Oh, I'm gonna.
True. I have a question though. Could you say a little bit more about the discourse analysis? You didn't see much in the discourse, right? Findings correlated with discourse. But can you say a little bit more about what you analyzed in the discourse?
So these were in the observations, and what we were looking at were the level, the number and depth of exchanges, essentially between students and teachers, between students and students. So, you know, at a lowest level, the teacher is just giving a lecture, right? And there's no response. The you know, a lower level would be one where there are a few questions, but there's not really to sort of probing and getting some responses, but not a real interaction. At the highest levels, you start seeing an exchange of ideas and playing off of ideas and building on ideas and that sort of thing.
So there just wasn't enough data, you know, sort of along that continuum to get any significance with your measures?
We just didn't see that related to the knowledge itself, you know, and so I think that, you know, one of the things that a knowledge assessment is not good at all is getting at discourse, right? So there's a situation where the measure is actually kind of disconnected, right? We can know what teachers know, but we don't get any information. They might say, oh, it's good to talk to kids, but that's not the kind of question we ask. Right. So anything about the social, you know, the discourse involves so many social dynamics and things like that, that a knowledge assessment's never going to pick up.
How does it respond to Dan's question? Whether we see the teachers who deny the content knowledge but have pedagogical knowledge. The model that was used here does not account for the teachers as you correctly found, but we looked at specific test items. And what we found is that if a test item asks if the content part, content knowledge, strict content knowledge, asks the teachers for some foundational idea, for example, how to define a system to analyze a problem solving energy, and the teachers don't understand this foundational idea, that it's not experimentally testable, it's an agreement in a way, how you go about analyzing energy problems. Then the teachers cannot do well on the pedagogical component of the problem. However, we also found questions where that ask for the content knowledge that is, although important, but you can figure it out by doing an experiment, for example. If you don't know, but you know that you can test your ideas experimentally, you will be okay. And on this kind of question, the teachers who answered the content part incorrectly gave a correct response with a correct explanation why they chose this response. So in a different paper that we submitted, we said that we need to look at different, we cannot just say this is content knowledge. There are different kinds of content knowledge, and some content knowledge is necessary. So you don't have it, you cannot respond to student ideas, but some aspects of the content knowledge, if you don't have, but you know how physics works as a science, basically you know science practices, you'll be okay.
Okay, here's a question from someone viewing on GoToMeeting. Drew, do you think communication skills of a teacher also matter in what they teach? For example, a teacher may have good content knowledge, but they may not be able to put it across properly.
Right. Yes. So I mean, absolutely. Right. I mean, as I said from the get-go, we are not capturing everything about teaching, but there are lots of situations, and we're discovering some of these things where there are factors that influence what we see, and certainly having knowledge by itself is not sufficient to have good teaching practice. And university teaching is probably a very good example of that. There's lots of experts in lots of classes that don't do a particularly good job of teaching because there's lots of communication issues and social issues that have not been that aren't optimal. Yeah.
I'm just trying to understand, like, that idea that like content knowledge is necessary but not sufficient. So, like the basic idea of content knowledge for teaching. Would you expect that there would be more people in this sort of middle category of like you're talking, like a faculty, a physics faculty, where they have really strong content, but they don't have this additional component that allows them to relate to students and help with teaching? Like you have a very small proportion. I guess I'm wondering if the implications are, at least for teachers or maybe high school teachers, that these things develop together. That this knowledge, like you're kind of saying, you kind of learn knowledge from teaching, and you learn about teaching.
Well, yeah, and the knowledge caps it, right? If you don't have the content knowledge, it caps it. I will say this, that there was another study done by other colleagues who studied mathematics, and they did study math majors, right? So they did a similar kind of study. And one of the things they found, and I think we see at least some of that, is that people who really know their content can figure out some of these problems and work it through. So they may not automatically recognize it, but they can do reasonably well on at least the pedagogical test because they can reason through it in certain ways. But that doesn't mean that they could teach successfully either, right? They're still working in a paper and pencil kind of form, computerized test format. So I think I guess I was maybe a little surprised that we didn't see anybody in the middle. Now it's only we have a lot of people. I don't know. We did not see it. And of course, some of it's an artifact of the items that we have. It's still a relatively small sample, but this is our first cut at that.
The students, teachers, and having neither CK and both. The presentation.
Where there was the students were talking about the problem.
No, the percentages of students, teachers, and both participants.
Yeah.
The experts and the teachers, in later classes.
Yeah.
So the question is, do you see any difference with the teachers have been for teachers having physics background and not having physics background?
Great question. Charlie's looking at that right now. So we have it, but I do expect it to be even more quite different. In fact, I expect, we'll see. I mean, my prediction is that they're the ones that are going to be in this area.
And also in the physics student sample, we have some participants who are in the physics teacher preparation programs that are not separated here. So we separate them, we might get different results here too. It's just the project over 5 years collected so much data that maybe 55 years will be needed to analyze them all.
And another small question here. Do you have students from the first year, second year, you making that distinction or not?
So we had 2 years of data collection. Is that, oh, you mean in this group here?
In this group?
We have that data. It just gets small, it
I
gets,
don't think so. I think they're all close to the seniors, juniors and seniors.
we have data on how
Yeah, but
long.
we don't have freshmen.
Right. No, they had to be declared majors for one thing. So,
They're all students who learn anything many times. That is what we were assessing on the test. No question about it.
Is your research informing practices of alternate group teaching? Because when I'm listening to this, I'm thinking about people that go alternate group, and in many cases, because they may have content knowledge but not pedagogical knowledge, they have trouble in the classroom. So is any discussion?
we haven't entered into any of those discussions at this point. It's an interesting issue, though. What are the pedagogical experiences that you need to take advantage of the content knowledge you bring? I mean, that's a teacher ed general problem.
Right. No, I only bring that up
Yeah.
because I've seen personally people that are experts in
Sure.
fields coming into public schools and they don't succeed
Right.
because they just don't have the skills to communicate their knowledge. And it seems that your research is confirming that.
Yeah. Interesting. Thanks.
Were you surprised by the number of teachers with this experience who had either discipline or pedagogical?
No. No, and I say that just looking at lots of other data we've looked at in other fields, and there's work to be done.
So was the underlying assumption, you touched on this a little bit more, was the underlying assumption that the content knowledge of an undergraduate student would be essentially equivalent to the content knowledge of a graduate student?
Right. So we were trying to say what sort of a equivalent group, right, that would have one thing and not the other. So we said, let's pick people who have similar academic backgrounds. And in some ways they matched, in some ways they didn't. So they matched in terms of their major with the physics, engineering kind of people that we had, right, the best scorers on the teacher group. But they don't match in that the teachers, I think, become more focused on the stuff they teach, right? So over the years, they may have less breadth of their physics. They forget a lot of stuff that they're not teaching, but they remember a lot about what they have to teach. Whereas these students this was one piece of this large body of knowledge that they're engaged in right now. So it's not a perfect match, but it's as good as we could get.
Were you at all concerned that, I guess I'm trying to think of, if I'm an undergraduate physics student and I'm trying to answer these, I'm not an educator. I've never heard of teaching whatever stuff in front of a room, and I'm being asked about pedagogical knowledge. Were you concerned about comprehension of what the questions are asking?
Yeah, well, if you look at the items, we never ask them about, we don't throw in educational jargon, right? So they're just questions about practice. They're saying, what problem would you give to these kids? What's a good question to ask the students that would prompt their thinking? So we stay away from all this jargon stuff. We save that for you guys.
Right, but I'm even saying, maybe, I guess what I would be concerned about is whether or not they would, by no fault of their own, not have the appropriate language to describe what they're looking for. Not saying.
Well, certainly the physics students, they'd enter into things where they'd say, I'm not, they would not be as they'd enter into things that seem more distal from them. But for the teachers, one of the things we do with these cognitive interviews, we say to them, does this seem like a reasonable scenario? Is this something you would experience in your classroom? And we get affirmation for that. So we, all the folks who worked on this, developing, like Eugenia, all the people who lead it, have been deep physics teaching experience. So, you know, so these were grounded in real practice. They weren't esoteric kinds of items. Yeah, I think. Eli, you had another question?
Yeah. So I'm like, in terms of the implications for measuring teacher quality, like one possibility with your overall framework is that you need multiple measures, but you didn't really report the integration of the measures yet. So I guess that's kind of still to come. But another implication seems to be the sort of specificity aspect, like, or I forget which part of, it's not really, I'm not sure it's the underrepresentation.
The evidential connections.
Yeah.
Yeah.
Like, do you see that as the implication? Like, that's why you're getting higher correlations. That's why you're getting that you're assessing a more specific thing, and kind of what you're talking about, the teachers, they learn their content for their lessons, and they know it pretty well. And like, is that one of the implications of this, is that you feel like measuring of teaching quality, it needs to be more local, but more like specific in a sense?
I think our theories have to be developed out of that, right? If our theories are just based on general traits, like somebody's high in this thing and low in this thing, and you know, they do better on this other thing at some level, we're left with these really impoverished kinds of understanding of what teaching is and what these relationships are. And a lot of our policies are built on those sorts of things. And we say, oh, this doesn't matter that much. Like, you know, there are lots of conclusions that say, oh, knowledge doesn't matter that much because these correlations are so low. And I think that's part of it, is a residue of how we measure these things and collect our evidence. So these are, if you were doing a large-scale survey work, you'd still have these grosser measures. But that still may be underestimating the true relationships that exist between these various constructs. And so this is a demonstration project to try to, you know, raise that point.
I believe you said you found that the length of teaching experience didn't significantly correlate to their scores. I was wondering if there are any plans to investigate what activities or experiences or interventions would improve this kind of knowledge.
That's another project, but that's a great question. Yeah, I don't know the answer to that. You know, and again, this is our sample. I would say, if you ever want to do a survey study of teachers, like that involve any assessment or something, just go with physics teachers. They're great. They say yes. Like, when, you know, when we put out a request for people to take these assessments, it's the only study I've ever been involved in where people just, we filled it up in like no time. And I think, you know, I think it is the residue of people who are relatively successful academically. They like to solve puzzles and tests and things like that. And so if you gave it to elementary teachers, I know we have, you know, done everything we can to fill up the samples that we'd like to have. This was unique. So they're different. And so I don't know, to answer your question, I'm not sure exactly where the, what those experiences are, but those are critical things that as a field we should be focusing on. And I think one of the reasons that teacher ed has moved more and more to sort of field-based experiences earlier and earlier is to give exactly the kinds of experiences that might raise those kinds of, that kind of understanding.
I think we can actually answer Josh's question, because for many teachers in this 32 teacher sample, we know exactly what kind of preparation they had and how we can probably see whether this preparation affected what they're doing, because we know a lot about Seattle teachers. They went through their workshops, and some of our teachers went through known programs. So we can probably answer some of these questions, even with the existing data.
We can. And you know, if you have Eugenia as a professor, you generally do pretty well. Not always. Not always. Okay, so thank you all very much. Next week is, Okay, so next week we have Milagros Nores from NEAR, who's going to be talking about some work on early childhood education in Chile. So please join us.
Yes.